With that, let me introduce our first speaker. Dr. Becky Larson is a professor at UW-Madison in the Department of Biological Systems Engineering, and she is going to give us a presentation broadly about manure management processes and technology.
Good morning. My name is Becky Larson. I'm from the Biological Systems Engineering Department at UW-Madison. I also have an extension appointment as a specialist through the University of Wisconsin Extension. My primary focus, I think my title is officially a bio-waste engineer, but my focus since I've been in Wisconsin has primarily been with manure. So I work a lot on manure management, handling, etc. So there's, I focus a lot on technologies of processing, as well as handling and application methods, and maybe even a bigger portion of that are all the environmental impacts or mitigating those impacts. So that's a big part of my research focus as well. So I'm going to talk a little bit today just about the technology and operation. I think a lot of us might not be aware with changing practices in agriculture what's actually happening on a farmstead. So what I brought is a lot of pictures of some of the ways in which we produce manure, we haul manure, we land apply it, and all the different technologies that are out there. And then I'm going to take a little bit of time to focus specifically on some of the manure irrigation technologies and what's available out there, what producers are using, and hopefully you'll get a better idea of what the systems are. Okay, so I wanted to talk briefly about, here we have an old manure spreader. You can see it's pulled by a tractor, but this is a old, pulled by horse and buggy type style. So I just wanted to make it clear that manure issues have been around for a very, very long time. We've been dealing with manure since we've had livestock and animal husbandry, etc. So we've been dealing with this. I even recently saw a presentation all about the history of manure. I find that pretty interesting. Maybe some of you don't. But it has been an issue for a really long time. Okay, I want to talk a little bit about the cycle of manure and what our current practices kind of focus on. So you can see here we go from crops to feed storage to the animal, whatever animal that might be, which produces manure. Then we can go through some treatment processes, some processing, some handling. On some facilities we do some storage, and then we'll go back onto the land. So almost all manure at this point is still land applied, right? So we use all this manure to provide nutrients, to provide soil health benefits. Okay, has a lot of organic matter, has a lot of nutrients. This allows us to reduce some of our other inputs. As you can imagine, if I'm growing a certain amount of corn, I'm going to need a certain amount of nutrients, a certain amount of other components that go into producing that plant. I can either supply those, right? If we didn't put anything on the land, we'd exhaust our soil capabilities, and we wouldn't have the growth of product that we do, right? So we can either apply manure, or we can apply synthetic or chemical fertilizers, but we do have to kind of keep this rotation going. So this type of cycle is somewhat sustainable, right? We have hopefully this closed loop. Obviously we have losses in each of these steps to water, to air, to other things, but the idea here is we want to mitigate with some of the work that we're doing any of the losses from this cycle that we see. Okay, so I want to talk a little bit about manure systems. They've become very complicated. I think a lot of people, when I get into a manure room on a large facility, there's so many pieces, I get kind of excited. Maybe I'm the only one that gets that excited, but it's sometimes hard for me to even follow which pieces of equipment they're using in what sequence and what those pieces of equipment are actually doing. So you can see, in the green over here we have manure production. Okay, so I'm just going to deal with from production to land application. So we're stuck in the manure cycle. Now I'm not going to talk about the feed and the cropping systems quite at this point. But so when I'm producing manure, I can go directly to land application, right? You can imagine a lot of smaller facilities that don't have the capabilities to do some processing or storage. They'll produce manure each day, and then each day it goes right out onto land application. Okay, direct process. Some other facilities might go through what these gray boxes represent or some processing steps. So we have lots of different processing for manure. Some of the big ones that we see in mostly dairy here in Wisconsin are sand removal. So they use sand for bedding, so they'll have systems that separate sand. They'll separate solids, so the solid particles of manure will be separated into a stream as compared to the liquids. I think a lot of people have heard about anaerobic digestion. So we'll put it through a digester and produce biogas, and then there's lots of other advanced treatment processes. Now these aren't individual, that I just use one and not the others. I can use these in sequence. Okay, so there's lots of different pieces that can go together. And then I can have storage. So maybe I have processing and no storage, somewhat unusual, or maybe I have storage and no processing, probably more common. Okay, so storage just allows us to better manage our manure application. You can imagine without storage, I have to haul and land apply manure on a regular basis. Okay, we know that land applying at certain times of the year during precipitation events, in the winter after snowmelt can lead to significant losses, particularly affecting water quality. So we've made these decisions, right, to implement this storage system to try to better manage when we can apply manure so that we can mitigate some of the impacts from that. Now this is kind of a busy slide, but I just wanted to give you an idea of These systems can be complicated. In a manure storage is not necessarily always just manure, okay? We have lots of other sources of wastewater from around the farm facility. So there's milk house waste. You can imagine when I milk an animal, not all of the milk goes directly to be, excuse me, being able to be produced. And then not all runoff. And other things can be directly discharged. Excuse me. I'm like, I think I left it in the car. I'm sorry. But you can see that these various blue arrows kind of represent traveling paths from different parts of the farm that we may or may not put through some of the things. Thank you so much. I appreciate it. I'm sorry. Whoa. Okay. So you can see that there's many different components on the farm. Not all of these are necessarily always there, but these are all components that can be there. I just want to point out, and you can look at this in a little more detail if you want, but typically the 6 kind of areas that we see with manure management systems are 1, production. So we have the production, then we have the collection of manure, then we can go through some treatment processes, then we have storage, then we have a transfer system to the field, and then we have the utilization. So typically that's a field utilization. There are some other components that can be used in other ways. Right, so these are generally the 6 processes. Not all of these are required at every facility, but they're the processes that exist. Okay, so I want to talk a little bit about manure production. I think we can all kind of guess how manure is produced, but it's important to note that there's characteristics about production that affect manure. Okay, so whatever I feed animals can directly affect what the concentrations are in the manure. Okay, so I have different feed rations, I have different ways of feeding, timing of feeding, all these things, different animals, they're different microbiology, produce different constituents in the manure. Now you can imagine they eat, they drink, and of course they poop. Okay, so we have all this manure. It's not always just manure though. So we have urine, again, all those other components that go within there. The thing to remember is manure composition can be really variable, okay? It's feed, the type of animal, the environmental conditions, you know, even the things that change within the animal. Once it's excreted, we can have hotter temperatures, colder temperatures, you know, so it changes the nutrient concentration. It changes if the nutrients are in organic or inorganic form. It changes the organic matter content, the water content, how many fibers, and of course, what you're probably all here for today is how the pathogen content might change. I'm not going to talk a lot about the pathogen part because Mark, who will talk next, will focus a bit on that. But these things change all of the time. So it's complicated in manure to try to treat it as one product. Okay, so it's a difficult area to work in, and it's difficult to use one system that will work for everybody. Okay, it changes from farm to farm, animal to animal, so it's important that people understand that. So one of the important things that we think about when we're handling manure is percent solids. You can see various types of animals, they give charts about what the total solids look like as it is excreted. So that changes. Here, you know, we see these are, you know, the data for these are a little bit old, but we see for dairy in Wisconsin, they used to give an average of maybe 12 to 13% solids. That's changed a bit since we handle our manure a little bit differently. Our feed rations have changed. Our practices concerning animal health and changing waters and sprinklers and other things have added a bit more liquid to these systems. So I'd say on average we used to see this kind of 13%, but that includes a whole range of things. I'd say typically now a lot of facilities are dealing with slurry manure. So you can see we kind of separate manure into different categories. We have liquid manure, which you can pump very easily, right? It has the consistency almost of water. You know, we measure things like density and other things, and it's very similar to water characteristics at a really low percent solids. Slurries are a little bit thicker. They require special pumps. They have more solids. They're harder to move. And then we get to semi-solids where it's too thick to pump, but you can't scoop it. Then we have solid manure, which you can imagine is stacking and other things. Today we're going to focus primarily on these slurry and liquid systems. Okay, so now we're dealing with a lot of these in Wisconsin. We've changed bedding situations and feed and all that, so that really plays a part in where we're dealing here. Not to say there isn't solid handling systems and people who have solid manure, etc., but primarily today we're going to be talking about this liquid and slurry systems. Okay, so now a little more interesting for you to watch. I gave you a little bit of background. I'm going to run through some pictures of what these systems really look like. Okay, so we have manure collection from a barn. Okay, so a lot of the larger facilities and a number of the small ones have freestall or tie stall barns, and we collect manure from those. There's a variety of different collection methods. Here you can see a skid steer. Sometimes here you can see that there's a wire there. We can use automatic alley scrapers that scrape the manure up, but regularly throughout the day to maintain a clean environment for the animals, we have to collect the manure. You can see here, there's a location where then that manure is scraped into a pit. Okay, so that's a collection method where we've removed it from the barn. There's flush systems. You can see I can push manure with my skid scraper into this type of a channel, which then I flush with recycle water. So that's manure that has gone through some other processes, low solids, and then I'll flush the other manure in the barn out to wherever my storage or location for loading might be. Here's an alley system. So I can also flush an alley. Okay, so I can move all that manure out of the barn with a flush system and flush the entire alley as well. So there's lots of different, this isn't even comprehensive, but I just wanted to get you an idea of what the scope of some of these looks like. Now I want to move on to the processing step. So a lot of people talk about digesters. They become pretty popular in Wisconsin. And digesters are important in certain ways. So they can function to change our nutrient contents. They can impact our pathogen contents. They can do various things. The main function of digesters is obviously to produce biogas. So we use biogas to then go into some kind of electrical generation or other end gas use. And then after the digestion, we have what we call digestate. So nowhere in this process do we lose the manure, right? Manure goes into a digester, manure comes out of a digester. The characteristics, again, may have changed, but we in no way lose the manure. It doesn't magically disappear. One of the other things that I've heard a lot about digesters is people think there's solutions for things like phosphorus. These are closed system. Whatever phosphorus goes into a digester comes out of a digester. Okay? Everything you can think of the components within manure that go into a digester come back out. The only thing is we've lost a significant amount of carbon to some of the biogas, methane and carbon dioxide. So I wanted to talk a little bit about the nutrients. There are some changes to the nutrients that happen. So you can see this is a total nitrogen measurement. So I can see into the facilities in blue and out of the facilities in red. You see a few different changes. This is a study in New York. We've also completed a study in Wisconsin that shows a little similar bars, but that you see, there we go, sorry, that you can see that the nitrogen stays relatively same from input to output. I'd say any differences you see, very minute amounts are lost through the biogas, and then it's difficult to sample. You can imagine I'm sampling one end and the other week after week. So any of these small variabilities can sometimes be attributed to the sampling method. The one thing you can see with nitrogen is that we have changes in the format. So TKN, or total nitrogen, represents the organic and the inorganic. Okay, so I have the same amount of total nitrogen, but my amount of ammonia increases after I go through digestion. Okay, so I have converted from an organic form to an inorganic form. So the same total amount of nitrogen is there, but the format of the nitrogen has changed. Phosphorus, you can see, is very similar, right? So, trying to force me along here. Okay, so I want to talk a little bit about now separators. So another treatment process is actually separating the solids from the liquid. Now, a lot of digester systems have this system tied to it. Actually, I don't know of any digesters in the state that have a digester and don't have some kind of solid-liquid separation. So solid-liquid separation is where you start to get some manure management benefits. Okay, so you can imagine I put this slurry or liquid slurry into a separator, and I end up with a solid component and a liquid component. Now, there's many different types of separators. I've got a few pictures of one. Here's a screw press. This just pushes the solid manure out the end. You can think of it just like a screw. Just pushes it out the end, and then in a little, right down here, the liquids are pushed through that. So it uses a screen to kind of separate the two. Okay, you can see this rotating drum screen. You can see here the solids again are caught within the drum. The liquids spread to the outside. There's inclined screens. So we have many different methods, centrifuges, all types of things, and they perform a little differently, right? They have different amounts of moisture content in the solids, different amount of nutrients in the solids as compared to the liquids, but they all now separate this into two products, which I handled very differently. Okay? So you can see the moisture of solids can change, right? So before we went to maybe something around 8% moisture, or I'm sorry, around 90% moisture, and we've reduced it in the solids to somewhere between 65, 70, 75. Okay, so you can see now I have a kind of solid product, lower moisture product, and a very liquid product with less solids in it. You can see some of the benefits of how we can manage this better is you can see here kind of the break. So if we think of this as 100%, the bar represents all of the phosphorus within manure. This is how it fractionates when it goes through a separation process. So depending upon my separator, I can get a pretty large amount of that phosphorus to be in the higher concentrated solid. Right? So you can imagine I can now deal with this higher concentrated phosphorus solution versus a lower one. Right? So we also get this breakup with nitrogen as well. So the way you can kind of see this a little more easily is if you look at this bottom chart that I have here, when manure, and this is on average, some farms have different processes, more advanced processes that can change these ratios, but on average what we saw on the study in Wisconsin is that we went into typical manure, before it went through these separation processes, had a nitrogen to phosphorus ratio of 3:1. Okay? Now the liquid now has a nitrogen to phosphorus ratio of 4:1. Okay? And the solid is about a 1:1. Okay, so you can see I have more phosphorus as compared to nitrogen in these solid manures. Okay, so now I can balance the liquid manure a little better where they might need more nitrogen for plants. It just creates some ability for me to have some flexibility in application to apply certain products where they may be needed. I want to talk a little bit about sand separation. It's another process within those treatment processes. It's not quite as important for some reasons. We do it a lot for managing equipment farther down the line. As you can imagine, sand and mechanical equipment don't love each other so much. It causes a lot of wear and tear. But these systems are important because they do affect total solids concentration. Some of nutrients can be lost with this sand separation. So you can see here's the liquid coming out of that piece. There's lots of advanced treatment systems as well. So you'll see some of these around the state. This is a phosphorus removal system. So it's a tubular removal system where we can have increased phosphorus removal. We have polymer systems which use dissolved air flotation, which can increase solids and other kind of removal. These advanced systems at this point aren't really done economically yet. So I would say in engineering we could clean the water to clean, right? So we could make it so you could drink it, turn manure into water. But the cost of that would be unreasonable. Okay, so even think about your wastewater treatment plant. They have standards they have to meet. They could make the water drinkable out of a wastewater treatment plant, but the cost to everybody would be extremely high, right? So they set standards which they think will not have as much of an impact, or they do some impact assessment so they can determine what those standards should be to discharge some of those waters. Same kind of situation we have with facilities, and particularly the permitted ones. So the next step is manure storage. You can see here this is a high solids manure storage. You can see it kind of forms this crust on the top. This is a concrete basin. We do have solid storage. All right, we're not going to talk a lot about that today, but it does exist as well. There are rules about manure storages. It's a highly involved process to make sure you're following the regulations to limit leakage and to limit emissions and other things that may affect the environment from these types of systems. This is the application method of solid storage. I'm not going to go through solids that much, but I wanted you to realize it's a different kind of process when I have solid manure from collection to application than when I'm dealing with liquid manure. Liquid manure, I have lots of different systems. So you saw that concrete basin first. Here's an above ground storage, right? So we have rules about where we can use different types of storages based on groundwater concerns, surface water concerns, other issues related to environmental and operational practices. This is another lagoon. You can see this one has many less solids. You don't see as much of that on top. And with this system, we can see a multi-basin system, right? So I might put all my manure in one giant system. I might divide it into separate basins to, again, increase some removal within certain basins. So this is the first basin of this system. You can see it then goes into an overflow and goes into a second basin where we have a lower amount of solids. Okay, here's kind of a picture of one of those all in one shot. It's hard with these large facilities to get everything. I'm not the greatest photographer. Okay, so you can see stage 1 and stage 2. Okay, so there can be multiple stages. There can be one stage. We have lots of different designs. We can have small initial basins to remove some of the solids, but all of this impacts the characteristics of the manure as it flows through these processes. Okay, so a little bit now about manure transport. So I have in this storage, I have all this manure now. What do I do with it, right? So typically, I'll agitate my lagoon before I move it out. So you can see this is a picture of an agitation equipment. Okay, so I'll try to, this was at that big solid lagoon that I showed you the picture of before. So you can see just after a few minutes of operation, they've broken up the solids and resuspended it to be able to pump this out to the field. There's lots of types of agitation equipment out there. So we agitate, and then we move to some kind of collection system. You can see this one floats in the manure, and the manure is then sucked through the top and then applied. So I can have pumps right on my application or my agitation equipment. I can draw from permanent pipes within the manure storage. There's lots of different designs of how I then move the manure from the storage into the line out to the field. Okay. So there's different ways after I agitate and pump out of the manure storage that I'm going to get the manure out to the field. Okay, so here you can see they can fill tankers, right? These tankers can be trucks, a truck with a tanker on it, a tractor pulling a tanker, right? There's a lot of different ways that we can do that. Obviously, there's concerns here about road weight issues and other things that we've recently seen that we can have some concerns of hauling manure in this manner. So some producers have moved to pumping and transporting manure through pipelines. So you can see this is one set of pipeline. This is what we call like a flexible hose, or eventually out in the field we can call it a drag hose. But you can see you can move this hose from one location to another. So this is not permanent. Okay, I can move this hose around to run to various locations that I would like the manure to end up on eventually. Another option is to do a more permanent system where I bury lines underground, and then you can see this riser comes up, and I can connect some of those semi-permanent hoses to this actually out in the field. Okay, there's different designs. There's a lot of requirements about how you have to design these, pressure testing, how you can test it for leaks and other things. So there's a lot of rules about designing these systems to ensure that we're not getting certain types of leakage out in as manure travels through it. All right, now I want to talk a little bit about application methods. So I've made manure, I've collected it, stored it, got it to the field. Now how do I apply it? So one of the things I think I hear a lot about certain types of application is I don't want to see this type of application, or I think there's a problem with this type of application. But the thing is, it's not a certain type of application or nothing, right? So these fields are permitted and allowed by nutrient management rules to be able to apply manure, okay? Regardless of the method you use, they have to use the same amount of manure on that field, okay? So they do things like soil tests, test the manure, and then they have certain application rates in which they can apply the manure. So no matter what application method I use, I'm still going to be held to this same certain amount that I can apply based on my nutrient management plan. Okay, so the first application method you can see here is a broadcast, a surface broadcast. So here there's lots of different types of tanker designs, but you can see it's broadcast from the top of the tanker and just surface applied onto the land. Okay, so you can see it's sprayed from a top. Here's one with a lower configuration. I can put a spray boom. So there's lots of different types of these tankers. Then we saw some systems where we started to have these drop hoses. So we had a lower application method. So these are used sometimes to get the spray a little lower to the ground. We have injection methods where you can see this is on the back of a tanker where we open the ground, we inject the manure into the hole, and then we close the soil back over it. So you can see that's that same tanker in operation. You can see it's cutting these rows in and injecting the manure. And then you can see the ground after it. It's completely covered within the ground. There's different advantages and different disadvantages to all of these systems. I do want to show you that these systems can be behind a tanker. Okay, so you can tanker it out to the field and you can use any one of those application systems, or I can do something called a drag hose. All right, so I connect the hose. You remember that riser picture I showed you? You might have a riser or some non-permanent hosing that runs out to your field. I'll connect the hose right to the back of the tractor. Okay, so the manure, you can see here a better picture, goes right into the tractor here and then can be used by any of those implements. So typically when I drag hose, a lot of people will do the injection. Some will do still surface application, but it's just another method of application. You can see here the hose just drags along behind the tractor as it moves in the field. Okay, so now I want to talk about what we're all here to talk about. Hopefully the last 15 minutes I'll spend talking about manure irrigation equipment. Okay, so we've shown all these other things. This is now just another application equipment that I have here. Okay. When I talk about some of those other systems, you can see some of them can have benefit if you think about the injection system, right? I might reduce my odors that way. I might reduce emissions. I might reduce surface runoff, but there could be more significant groundwater impacts potentially, right? So there's lots of different trade-offs you make between these different application methods. You can imagine too, when I'm talking about application, tankering has road weight issues and can be rather costly. Okay, not only to a community, but to the producer as well. So manure irrigation equipment, I'm going to talk about two main types. There's quite a few different types of irrigation equipment that are out there, but the main two that are used here in Wisconsin or around the U.S. are what we call a center pivot system and a traveling gun system. So before I go into a piece of manure irrigation equipment, there's things I have to do to manure before I can even run through these lines, right? I have to have a lower solids content. So if you imagine trying to pump some of that slurry with a lot of particles through pumps, through nozzles, through other things that are part of that equipment, it's not really possible. So I have to remove a lot of the solids from that before I can go into it. When I use irrigation equipment, again, we have that decreased application cost, so it saves maybe 1 cent a gallon, but again, that's largely variable depending upon what your costs are. You can imagine if I have to drive to a farther away field, it costs me more. It's different, okay? It can have water quality benefits. So if you can imagine, when I do all those other types of application methods, I cannot do that once the crop has appeared, okay? So what I have to do is I have to land apply in the fall or the spring or both, okay? But I can't do it numerous times throughout the season. So one of the benefits of these systems is I can apply the manure when the plant might need it the most. Okay, so you can imagine we can get some nutrient and other runoff issues, water quality issues when I'm applying a huge volume at once. Remember I said you can only apply still the same amount of manure, So now I can apply it maybe 2 to 3 times through various cropping systems. And typically what a producer will do is apply it a small amount before the crop's planted, plant the crop, then do another application when the crop is low. And then if I do 2 crops within one season, I might do some more applications in between. So you can see that there can be some benefits there when done correctly. Air quality and pathogen transport. Those are some of the things we're working on, talking about, and we'll get to those a little bit later about what the impacts of those may be. Odor will always be an issue, all right? When you go through a manure irrigation system, we see a lot of these odor-causing compounds have now been aerosolized, okay? So we are going to get a decent amount of odor from these systems, okay? You're never going to get away from odor. Okay, there is going to be some odor. There are mitigation techniques for certain kinds of odor, but there is always going to be some odor associated with these application methods. And then again, there's a wide variety of rules about these systems throughout the country, throughout the world. It's been very different how people have interpreted the information that's out there. And I'll say the information that is available about how these systems perform is extremely limited. Okay, so not only manure irrigation with pathogens, transport, and other things, but other manure application methods as well. Okay, so some previous research that's been done is we know that transport with irrigation of particles, maybe not pathogens in general, but particles are definitely affected by some physical properties of the droplets, right? So my shape, my size, the density of the material I'm irrigating can really affect drift, okay? Again, meteorological factors, you can imagine wind velocity is pretty big, so that can affect it as well. Okay, so relative humidity, temperature, we see a lot of these things can affect transport of pathogens and other things. We know certain things affect their survival, but unfortunately we don't know how all of these things play into these particular systems. So I'm going to run through some pictures so you can visualize a little bit about the irrigation system. Okay, so we require some pre-treatment. You can see here it went through some mechanical separation. All right, this is at one of the facilities, Randy, who will talk today. You can see he has a 3-stage lagoon. So you can see the difference from originally the first lagoon to the second and third lagoon. You can see here that you can even visualize the changes to the water, the manure characteristics. First system I now want to talk a little bit more specifically about is the traveling gun. You can see here this system sprays, and here that gun section, this reel is unwound. You start it up, and the gun is pulled towards the reel. You can see it has this circular pattern that swings back and forth. Okay, so here, so you can kind of visualize what that system looks like. Then we have a center pivot system. So these have one central location, and then we can spray around in a circular pattern. You can see this is the length of one here. This is one spray irrigating manure. So you can see the moisture on the ground. You can kind of see from wet to dry over here as well, where that wetting front may be, so how far that spray might be traveling. You can also see what the characteristics of the ground after it's been applied. You can see here, this is just another length shot of the system. They're motorized individually, the wheels, so you can look at the various components, and from in the field it's controlled and it moves at a rate in which you set it. This is the center location where we feed whatever product we want to put through the irrigation system. Here you can imagine I could run that line from this riser to connect the manure system. I can measure things like pressure. You can see the connection point here. I could connect water or I could connect manure. Again, you can see kind of that wetting front and what actual manure spray irrigation can look like. This is at another facility within Wisconsin. Okay, you can see these are drop nozzles here. So we have some what we call impact sprayers that can be along the top of the center pivot, or we can have these drop nozzles which drop down a few feet and lower the distance, the height of spray. There is the possibility of running manure and water through one system, but producers must demonstrate ways in which they will avoid contamination of a well that they're drawing from. So some can have a lot of check valves and backflow preventers. They've been using a lot of this with nitrogen applications in their center pivots for a long time. They can physically change the line, so I hook up water, and then I disconnect it, and I hook up manure. Or like the producer will see today, he has to pump into a reservoir into the water and then draw from that to avoid going back into the well. So I just want to talk about a few more characteristics. I think I'm running low on time here. So I want to give you an idea of what the nozzles look like, so you can see what that drop nozzle looks like. You can see this is some spray from that. We can control the pressures. We can control the height of drop nozzles to change what these spray patterns look like. You can see these drop nozzles are really low and close to the crop. These ones are a bit higher, spraying manure up here. That can be dependent upon how tall your crop might grow. You can see this is what kind of the application looks like. And then we talk a lot about this end gun system. So I have all these drop nozzles along the length of the center pivot, and then at the end I have something that functions similar like a impact sprinkler to that you saw in the traveling gun. So sometimes we'll turn these on, sometimes we'll shut them off. You can see this system has controls where you can program it. This is it in one part of its application. It was close to a setback, so the end gun turned off. And when it got to an area where there wasn't setback concerns, then the end gun automatically turned on. So there's lots of systems they can control. And they can control speed of travel, pressure of the system, nozzle type, end gun shut off. So there's lots of things that can be controlled. One of the producers, all of his people have iPads. They can control the pumps and the various pieces. There's really specialized things. So we can have wind shut off. So I have a wind measurement, and at a certain speed, I can shut off my irrigation system. And you can see here, you can even have sophisticated programs that can apply manure based on GIS maps at you. So you can see I can give different manure applications based on these pieces of the pie, as well as turning on and off different nozzles to give different application rates in different areas of the field. Okay, so I know that's a lot of information about manure systems. I hope I presented it in a way that you can understand it. But there are a lot of things we don't know. Okay, so there's lots of ways to control these systems. Is that enough to mitigate risk? Is it not? That's what we're trying to determine here. So what should our setback distances be? What kind of management practices can we use to mitigate transport? What does our risk assessment really say about what the impact of these systems? What kind of operational choices should I make? What kind of equipment choices should I make? And what kind of weather conditions should I be doing? Those are the things this work group is going to try to focus on. Now, the risk assessment and setback and pathogen-related things will also be focused on in the research, which we'll talk about in a little bit. Okay, I'm sorry I ran a little over time. But I want to thank you. My contact information is here. You're welcome to ask me questions. I don't think we have time for questions right now, but I will open it up for Mark.
Let's thank Dr. Larson. Thank you very much.
You did.